this class we will be seeing the design of an FIR filter. In the last class we have seen the design of an FIR filter for low pass filter. In this class it is ideal high pass filter. Okay, let us start the problem. The given problem is design an ideal high pass filter with a frequency response given as, the frequency response is given as HD of e to the j omega. D stands for desired frequency response. The desired frequency response is 1 for in between the range pi by 4 to pi. So, the omega value between pi by 4 to pi, mod omega value, value is 1 and is 0 for mod omega less than or equal to 4. So, we have to design an FIR filter for this desired frequency response for high pass filter. Find the value of n, find the value of h of n for capital N is equal to 11. So, here find the value of h of n and find h of z. H of n is known as impulse response and h of z is known as transfer function. For n is equal to 11 means for n is equal to 11 means for 11 samples. Let us start the solution. So, as you know, this topic is from the design of FIR filter using Fourier series method. So, what are the steps in Fourier series method? Desired frequency response HD of e to the j omega is given. Based on this, we first compute HD of n, that is a desired impulse response, and then compute the truncated impulse response h of n and then find its transfer function h of z. This h of z is not physically realizable because it is comprising positive terms of z or positive powers of z. So, for designing we need a physically realizable filter. So, we go for h dash of z. So, how h dash of z is coming? By multiplying h of z with z to the power of minus of n minus 1 by 2. So, these are the steps to be followed. First compute HD of n, h of n, h of z and h dash of z for the design of FIR filter using Fourier series method. So, this is the first step. HD of e to j omega is written. The definition which is given in the problem is to be written here. Is value is 1 for mod omega value ranging between pi by 4 to pi and is 0 for mod omega less than pi by 4. So, which is drawn here. So, this is ideal frequency response of high pass filter. HD of e to j omega value is 1 between pi by 4 to pi. So, it is between pi by 4 to pi, its value is 1 and it is shown in mod value. So, mod value means in between minus pi to minus pi by 4 also its value is 1. Okay. So, this is how, and mod omega less than equal to pi by 4, in between this range the value is 0. So, this is how we draw the frequency response based on the definition. So, after the first step, that is the desired frequency response we have written, now we have to compute HD of n. What is HD of n? Desired impulse response, that is the inverse Fourier transform of HD of e to the power j omega. Its formula is 1 by 2 pi minus pi to pi HD of e to the j omega e to the j omega n d omega. This is formula of HD of n. Substitute HD of e to j omega from this definition, above definition here. So, we can separate this integral into two parts as per this graph. One is ranging from minus pi to minus pi by 4, another integral is from pi by 4 to pi, which is written here as from minus pi to minus pi by 4. What is HD of e to j omega value? Its value is 1. And from the integral pi by 4 to pi by 4, what is HD of e to j omega value? 1. So, in this range its value is written as 1. So, integration we have written in the next step like this, and you know integration of e to the power j omega n d omega is how much? Integration of e to j omega n d omega, we are integrating with respect to omega, so it will come as e to the power of j omega n by j n. Okay. So, which I have written in the next step 1 by 2 pi. On integrating this one, we will get e to the power j omega n by j n based on this one, and the limits are ranging from minus pi to minus pi by 4, and this integration also gives e to the power j omega n by j n, because we are integrating with respect to omega. The limits are from pi by 4 to pi. Now, substitute the limits. E to the power 1 by 2 pi e to the power minus j pi by 4 n minus of e to the power of minus j pi n by j n. So, on substituting the limits for this term, we are getting like this, and for this term on putting the limits we will get, we are substituting omega value e to the power j pi n minus of lower limit e to the power j, omega value is now pi by 4 n divided by j n. Okay, so, we have substituted the limits, and now rearranging the terms to get it in the form of e to the power j theta minus of e to minus j theta by 2 j can be written as sin theta. So, on rearranging the terms, e to the power j pi n minus of e to the power j pi n, and here this is in the denominator part we are having 2 pi j n. So, I have taken pi n common outside and taken 2j in. So, it now becomes e to the power j pi n minus of e to minus j pi n by 2j minus of, now this term, this minus we have written here e to the power j pi by 4 n minus of, this is plus term. So, we are writing here minus e to minus j pi by 4 n by 2j. So, if you look at this equation now, this pi n let us assume as theta. So, it look like e to the power j theta minus of e to the minus j theta by 2j. So, what is this equation for? Sin theta. So, what is theta value here? Pi n. So, it is sin theta, theta is pi n. Here e to the power j pi by 4 n minus of e to the minus j pi by 4 of n. So, here it is sin pi by 4 of n. So, which I have written it here. So, this gives sin pi n and this term gives sin pi by 4 of n. So, we got finally h d of n is equal to 1 by pi n sin pi n minus sin pi by 4 of n. And how this n is varying? It is varying between minus infinity to infinity, and we are designing an FIR filter. So, how should be the impulse response? It should be finite in nature, but it is an infinite nature. So, next step is to truncate the HD of n. For truncating HD of n, we have the equation h of n. H of n is what? Truncated impulse response. H of n is equal to HD of n. H of n value will be equal to HD of n for mod n less than equal to n minus 1 by 2. N value is given as 11 in the question. So, 11 minus 1, that is 10 by 2 is 5. So, for mod n less than or equal to 5, H of n value will be equal to HD of n and is 0 otherwise. So, next step is to find h of 0, h of 1, h of 2, h of 3, h of 4 and h of 5. Okay. So, we have to find the truncated impulse response, and we know in the previous equation we got HD of n is 1 by pi n sin pi n minus sin pi by 4 of n. We got this HD of n. Now, from this HD of n we have to find h of 0. if we put n is equal to 0 here, it becomes indeterminate. So, we can't directly find h of 0. So, what we do? We say that this n is tending to 0. So, for finding h of 0, for n is equal to 0, h of 0, limit n tending to 0, hd of n. So, which is equal to limit n tending to 0 sin pi n by pi n minus sin pi by 4 of n by pi n. Okay, so, on opening the brackets, we can write the terms limit n tending to 0 sin pi n by pi n minus limit n tending to 0 sin pi by 4 n by pi n. Okay, and we know the equation when limit theta is tending to 0, sin theta by theta is 1. So, here what happened? This n is tending to 0. So, it becomes sin theta by theta. So, this term we can write it as 1. 1 minus limit n tending to 0. Now, here to this term, to make this as sin theta by theta form, multiply and divide by 4. So, here I have multiplied and divided by 4. So, I am getting here 1 by 4 sin pi by 4 n by pi by 4 of n. So, this is sin theta by theta when theta is tending to 0. So, now this term becomes 1. So, here we can write h of 0 is equal to 1 minus 1 by 4, which is equal to 0.75. Okay, next step. So, this limit part is only for h of 0. Coming to h of 1, h of 2, h of 3, h of 4, h of 5, we can directly substitute n value as 1, 2, 3, 4, 5. Okay. So, which is being done here. For symmetrical response, we know h of n is equal to h of minus n. So, what is h of 1? H of 1 will be equal to h of minus 1. So, we can substitute n value as 1, sin pi by n minus sin pi by 4 n by pi n. Substitute n value as 1, we will get it as sin pi minus sin pi by 4 by pi. On simplifying this, we are getting it as minus 0.225. Now, compute h of 2. H of 2 will be equal to h of minus 2. Substitute n value as 2 in this equation, sin 2 pi minus sin 2 pi by 4 by 2 pi. On simplifying, we will be getting it as minus 0.159. Next, compute h of 3 is equal to h of minus 3. Substitute n value as 3 in hd of n equation. So, sin 3 pi minus sin 3 pi by 4 by 3 pi, which is equal to minus 0.075. Next, we have to find h of 4, which is equal to h of minus 4. Substituting n is equal to 4, sin 4 pi minus sin pi by 4 pi. On simplifying, we are getting it as 0. Next, we find h of 5 is equal to h of minus 5, which is equal to sin 5 pi minus sin 5 pi by 4 by 5 pi, which is equal to 0.045. So, by this we completed computing h of 0, h of 1, h of 2, h of 3, h of 4 and h of 5. Next, we will find, so we got h of n values now, truncated impulse response. Next step is to find h of z. Okay. So, next step is to find the transfer function h of z. The transfer function of the filter is given by the equation h of z is equal to h of 0 plus summation n is equal to 1 to n minus 1 by 2 h of n bracket z of n plus z plus z to the power minus n. This is a transfer function equation of h of z, and we got h of 0 value as 0.75, and this capital N value is given as 11 in the question. So, 11 minus 1 means 10 by 2 is 5. So, n is varying from 1 to 5. H of n, z to the power of n plus z to the power of minus n. Now, expand this series, that is, first put n is equal to 1 plus n is equal to 2. On expanding the series, we get the transfer function h of z as 0.75 plus first n is equal to 1. From 1 to 5 we have to substitute. So, h of 1, h of 2, h of 3, h of 4, h of 5. So, when n is equal to 1, what it becomes? Z to the power 1 plus z to the power minus 1 plus h of 2, z to the power 2 plus z to the power minus 3 minus 2 plus h of 3, z to the power 3 plus z to the power minus 3 plus h of 4, z to the power of 4 plus z to the power of minus 4 plus h of 5, z to the power 5 plus z to the power minus 5. So, we got h of 0 value is 0.75, h of 1 value is minus 0.225, h of 2 value is minus 0.159, h of 3 value is minus 0.075, h of 4 value is 0. So, we have directly gone to h of 5, h of 5 value is 0.045, z to the power 5 plus z to the power minus 5. So, this is a transfer function we got, but it is not physically realizable because it is containing positive powers of z. To get negative physically realizable filter transfer function, we have to find h dash of z. H dash of z is equal to z to the power of minus of n minus 1 by 2 dot h of z, that is n is 11. So, 11 minus 1, 10 by 2, which is equal to 5. So, it is written as z to the power minus 5 h of z. Okay, so, we already got h of z here. We got this h of z. Now, multiply this complete equation with z to the power minus 5. Okay, on multiplying z to the power minus 5 dot h of z, this which we have written it here, and opening the bracket, after multiplying and simplifying, we are getting h dash of z is equal to 0.045 minus 0.075 z to the power minus 2 minus 0.159 z to the power minus 3 minus 0.225 z to the power minus 4 plus 0.75 z to the power minus 5 minus 0.225 z to the minus 6 minus 0.159 z to the power minus 7 minus 0.075 z to the minus 8 plus 0.045 z to the power minus 10. So, in this way we got h dash of z. I hope the solution you have understood. So, let me quickly summarize the solution what we have done. The desired frequency response hd of e to j omega is given. First, we have computed hd of n, which is known as the desired impulse response, computed by the formula hd of n is equal to, this is hd of n is equal to 1 by 2 pi hd of n. hd of n is equal to 1 by 2 pi minus pi to pi hd of e to j omega dot e to j omega n dot d omega. So, this is here the n is varying from infinity to infinity, and we are designing an FIR filter. We have to truncate this hd of n. So, this h of n is a truncated impulse response, which is telling h of n value is equal to hd of n for mod n less than equal to n minus 1 by 2 and is 0 otherwise. After getting the truncated impulse response, we computed the transfer function h of z, and this transfer function is not physically realizable. So, we are finding h dash of z. H dash of z is obtained by multiplying z to the power of minus of n minus 1 by 2 dot h of z. And how this h of z we are computing? H of z is equal to h of 0 plus summation n is equal to 1 to n minus 1 by 2 h of n z to the power of n plus z to the power of minus n. Okay, I hope you have understood the solution of design of ideal high pass filter, FIR filter by Fourier series method. Thank you. Good luck students. If you have any queries, post in the comment section.